Welcome everyone. I'm excited to introduce Chenglei from Stanford University, and today he'll be presenting on can LLMs generate novel research ideas? He's a second-year PhD student at Stanford NLP, who's co-advised by Tatsu Hashimoto and Di Yang, and his research lies at the intersection of NLP and HCI. Without further ado, I'll pass it over to you.
Thank you. Thank you everyone for coming, and thank you for inviting me. So today I'm going to talk about this whole research agenda on automating research. I'll start by talking about the big picture, and then I'll zoom in on our particular paper on generating research ideas. So what's the big picture? I think for all of us researchers, we all agree that scientific research is very important to drive the society forward. But research is difficult. There has been recent research showing that the pace of scientific research has been slowing down and papers are becoming less disruptive over time. And at the same time, we realize scaling up research is very difficult in the sense that it requires huge amount of human expertise and effort. At the same time, we realize large language models are getting better. Recent models like Claude 3.5 and OMS 01 are getting pretty impressive performance on a bunch of coding, math, and reasoning benchmarks. And some of my more optimistic AGI Pro friends will even say there'll be a point where large language models will be so smart that they can even automate some of the best human researchers like Alec Radford. I'm not sure if I agree with this exact timeline, but it does make us wonder if there will be some possibility where language models can do research for us. So I'm going to put forth a very concrete agenda, a concrete proposal for how language models might automate research. And this starts with a research idea generator that can generate a bunch of research ideas. And for each idea, I'm going to assume I can build a very good research idea executor that can quickly implement each idea and test out whether each idea works or does not work. And the beauty of this paradigm is that I can scale this up very quickly and test out tons of ideas for each research topic. Now, I would claim for this paradigm to succeed, we really need two things. First, we really need a very good idea generator. And secondly, we need to have an LLM system that can execute all these ideas correctly. So for this talk, I'll focus entirely on the first part, on generating good research ideas. And towards the end of the talk, I'll touch a little bit on the execution part. So let's dive into generating research ideas. Well, I want to first acknowledge that we're definitely not the first one to think about whether language models can generate ideas. In fact, a bunch of papers has been out even before us, and they have built all sorts of systems. I think it's fair to say that before our work, we don't really have a clear idea on whether LLMs are able to generate some really good ideas. The reason is all the prior works, they don't have any comparison with human baselines. So they'll give you a bunch of numbers along different metrics, but it's really hard to contextualize what those numbers really mean. So we decided that before moving on, we need to have some very good evaluation to know how good are the current generation of language models in terms of generating research ideas. And specifically, I want to understand two questions. I want to understand first whether language models can generate novel research ideas. And secondly, I want to understand for those language models to generate ideas, can they actually be executed as successful projects in the end? So I will have two studies targeting these two questions. In the first study, I'll recruit a bunch of experts. They will write ideas for us. And I'll compare the expert ideas with what my language model agent will generate. And then I will rely entirely on large-scale expert review to compare the human ideas and AI ideas. So that's a study that I'm going to focus on for the rest of the talk. But we also have another ongoing study where we're targeting the second question, where we're recruiting a bunch of experts to actually execute all those ideas into full projects. And then we're going to do another round of large-scale expert review based on the full projects so that we can know whether the outcomes are also good. I'll touch a little bit on this second part towards the end as well. So let's dive into part one of the story. This is really based on our recent paper, Can Large Language Models Generate Novel Research Ideas? This joint work with my advisors, Di and Tatsu. This is the outline of this agenda, and I'll first go through the high-level study design. So in the high level, we really want to compare two things. We want to compare human experts and AI agent on how well they can generate research ideas. So for human experts, we'll just have this human ideas condition where human expert will write ideas on those 7 NLP topics. And then for AI agent, we'll have two conditions. The first one is the AI ideas condition, where I just get the AI agent to generate all the ideas for me, and then I pick the best ones out of them. And I'm adding another condition called AI ideas plus human re-ranking. This is where I generate all the ideas with my AI agent, and then I will manually go to re-rank all those ideas and pick the best ones based on my own judgment. The reason why we're adding this third condition is that the intuition is it's possible that AI is able to generate some really good ideas, but it's varied across all the generations. So once you have an estimate of what's the upper bound of the best AI generated ideas, that's why we're doing this human re-ranking condition as well. So both of these are all AI generated ideas, just that the last one is picked by humans. So that's the three conditions we'll compare. I will talk about the topics that we asked both the agents and the human to generate ideas on. For this study, we really constrained the scope to prompting-based research. I know this might be a disappointment, so for some people who don't really like prompting research, but our rationale is, firstly, whether you like it or not, prompting is an active area of research. There are a bunch of prompting papers published at every NLP conference these days. And second of all, remember, we're going to do this execution study, where we're going to recruit a bunch of humans to actually execute each idea into the full project. So that means we want all the ideas to be somewhat easy to implement, and prompting-based research is really good for that purpose. So these are the 7 topics that I asked agents and humans to write ideas on. They include bias, coding, safety, multilingual, factuality, math, and uncertainty. So common topics that you will find in modern-day NLP conferences. And for all the human participants, I'll ask each of them to choose their favorite topic to write an idea on, and this is the distribution across all these different topics. For my AI agent, I will match this exact topic distribution. I will specify a format for both humans and language models to write ideas. So the format includes the title, the problem statement, the motivation, the proposed method, the experiment plan, the test case examples, and the fallback plan. Later on, I will show some concrete examples of what a general idea would look like.
So basically, they are all computer science related ideas?
Yes, all NLP topics. I will show some very concrete ideas towards the end of the talk. And this concern that when I give ideas for people to judge, there might be this confounder where some people might just pick up on writing styles, and we don't really want the writing style to be the main factor. So we do this style standardization thing where we use a language model to standardize the writing style of both human and LLM ideas so that they have the same writing styles. We manually check that this module only changed the wording and formatting, and without changing the original idea content. We did a small-scale human study where we asked 100 people in the lab to judge whether they can tell apart AI and human ideas. They only get random chance accuracy on this. So we take this as evidence that we are trying our best to mitigate this writing style confounder. So after I do this style standardization thing, I'll send all the AI and human ideas to the reviewers, and the review rubrics are mostly adapted from modern-day AI conferences. So yours is one inspiration. Specifically, we'll ask people to judge all the ideas along these dimensions. So they include novelty, excitement, feasibility, effectiveness, and an overall score. So for each metric, I'll ask for a score on the 1 to 10 scale, along with a free text rationale. So novelty and excitement are pretty aligned with how it's defined in modern-day AI reviewing. Feasibility here means whether they think the idea can actually be executed within reasonable resources. And effectiveness means if I actually execute the idea, do you think the proposed method can actually be the baselines? So those are the 2 additional dimensions there. Right, so just a recap, I'm going to compare across 3 conditions: human ideas, AI ideas, and AI ideas are re-ranked by humans. And then I'll send all of them to my expert reviewers to score. And the reviewers will know which one is which condition. All right, so that's the high-level study design. Any questions? Okay, so next I will go through the 2 branches that will generate the ideas for me, which is the idea generation agent and also the human experts. Let's start with the idea generation agent. So for our idea generation agent, we really want a simple but effective baseline here. And the high-level design principles are 2 ideas: retrieval augmentation and inference scaling. And I'll elaborate in the next few slides. So we'll give the research topic to the agent as input, and the agent will first go through this paper retrieval step, where it will generate a bunch of function calls of semantic scholar API to retrieve a bunch of relevant papers. And then the language model will do a round of re-ranking to find the most relevant ones. And I'll append those most relevant papers to the idea generation step where it does retrieval augmented generation. And I want to highlight that in this step, we want to massively over-generate the number of possible ideas. The intuition is that the more I generate, the more likely is that I'll find some good ideas among other generations. There's a limitation on the max output tokens since we're using cost 2.5 as the base model. So we're generating batches and we'll append the previously generated ideas into the current generation and ask the model to do not repeat itself over the different batches. After I generate tons of ideas, I want to do an automatic re-ranking to find the best ideas. And we tried a bunch of things for this idea ranking step. We realized that if you just ask the language model to score each idea out of 1 to 10, for example, it doesn't really work well. So what we end up doing is this pairwise comparison thing, where we give a pair of ideas to the agent, and then we ask, which one do you think is better? And for each winning idea, we will accumulate the score by 1. And we do this comparison for n runs. So n is just a hyperparameter here. And I will show some benchmark results on accurate data from last year. So in this table, the n here just means how many rounds of pairwise comparison I'm doing. You can treat that as a hyperparameter. And the top 10 means the top 10 AI ranked papers. And bottom 10 means the bottom 10 AI ranked papers. And the number here means what's the actual average score based on last year's accurate reviews. So you can see that for the top 10 AI ranked papers, they do have higher accurate scores. And for the bottom 10 AI ranked papers, they do have lower accurate scores. So the gap means the ranking step here is doing something in the right direction in distinguishing the better and worse ideas. So that's the idea ranking module. So this is a high-level design of the entire agent. Next, we'll talk a little bit about how we get a bunch of human experts to write ideas as a human expert baseline. So one of the most important bottlenecks in this entire study is how to recruit the best experts to establish this human baseline. We tried a bunch of things. So for example, we sent a bunch of Slack messages across a bunch of different NLP channels. I think I asked some friends at USC to help me forward the message as well. I sent out messages on Twitter, and I was wearing this t-shirt with my advisors' faces and NACO, trying to do some in-person recruitment as well. So we offer some reasonable compensation. So for writing an idea for us, you have 10 days to do so, and we'll compensate for your time by paying you $300. We'll also give some bonus for the best ideas. For reviewing, yes, go ahead.
What if they used an LLM to generate their idea?
So we asked everybody to sign an honor code in the beginning by saying you won't be using LLM. We also manually check through things just as a vibe check thing. But really, here I want to highlight that we are leveraging a lot of personal communication to make sure that people are invested in this task. Yeah, and back to this for reviewing ideas. Each person has 1 week to do so. We pay $25 for reviewing each idea. And again, our philosophy is all this money is just for compensation. All these PhD students, I am sure they have better things to do. They are contributing their time because they want to figure out the question to the study. So we appreciate all the effort. We treat money as a compensation rather than incentive here. And in the end, we recruited 49 people for writing ideas for us and 79 people for reviewing ideas for us. So a little bit over 100 total participants. Next, I'm gonna talk a little bit about the qualifications of all the human experts that we managed to recruit. On the left, I'm showing stats for the idea writing participants. On the right, I'm showing idea reviewing participants. So in the pie chart, I'm showing most people who participate in the study are PhD students. For reviewing, some of them are also postdocs. And here in the table, I'm trying to use some quantitative metrics to measure this pool of participants. So citation is a very proxy metric, but if we just look at the numbers for the idea writing participants, their average citation is around 477, and for idea reviewing participants, the average citation is 635, and all of them have at least 2 publications in a Google Scholar profile. So hopefully there's some evidence that we're recruiting people who have substantial research experience. And we're recruiting people from a wide range of institutions. Again, on the left, I'm showing people who did the idea writing task for us. On the right, I'm showing people who did the idea reviewing for us overall over 30 different institutions across many places. And you can see that USC has a lot of people who participate. So thank you for all those people. And apart from qualification, I also want to highlight people are actually putting a lot of effort in these tasks. So in this table, I'm showing on average, you can see that when writing ideas, people spend an average of 5.5 hours, and their idea is about 900 words long. And apart from stats, I also want to show some qualitative evidence. So I got this really nice email from one of the idea writing participants telling me that they realized this is a study about comparing human and AI on idea generation. So they want to spend more time trying to come up with better ideas so that the idea can be at least as good as AI. So hopefully there's some extra evidence showing that people are invested in this study and they have some intrinsic motivation more than just monetary compensation. And I'll also share some evidence showing people are putting efforts in the reviewing task as well. So here I'm showing people are spending an average of 30 minutes in reviewing each idea. And want to compare the length of the reviews with iClear data. So on average, each review is about 230 words long. iClear review, they have a different format. We don't really have the summary and question sections. So if you remove those sections and only count the words of the strengths and weakness sections, it's about 247 words long. So that's roughly comparable to our review length. So I would say people are generally writing thorough reviews in this task. And another data point is out of the roughly 300 reviews that we're getting, 80 of them actually provide links to existing papers in their rationales when justifying why the proposed method is not novel. So I think this extra evidence showing that people are putting in some real effort when they're reviewing papers. Later, I'll also show some concrete review examples to convince you about this. So summary of that section, we recruit a bunch of really good people to write ideas for us and review ideas for us. And they're putting some real effort. Yes.
Maybe I missed it. How many reviews did each participant write?
36.
36?
Yeah. Okay.
Thank you.
Any other questions? Yes.
So I'm convinced that the participants, especially writing the research idea, are pretty much devoted in writing these. But also I'm not entirely sure if they gave their absolutely best idea, because I mean that would mean idea leaks or
yes.
something like that. How would you how did you circumvent that probability?
Yeah, I agree with that point. I'm actually gonna talk about that point in later part of the talk, but briefly, you're absolutely right that it's difficult for us to get the best ideas, because if they have a really good idea that could win some awards at the conference, why don't we just work on those ideas themselves? Why would they submit their ideas to us instead? I'm gonna touch on that. I'll give you some stats later on to show that's indeed the case, and we'll address that limitation. Okay, so I talked about the AI agent and also the human experts that write ideas for us. And then I'll talk about the results when comparing across the different conditions. So I'm actually gonna give you the conclusions first. The way I'm gonna do this is I will run a bunch of different tests, statistical tests that compare different conditions. And the high-level principle is that if a conclusion holds across all the different tests, and then I will be making that conclusion. So there are three conclusions that I'll be making that hold across a bunch of different tests that I run that will count for different confounders. So I'll tell you those three conclusions first. The first one is that in terms of novelty score, AI ideas are better than human ideas, and also AI ideas plus human re-ranking are better than human ideas. And in terms of excitement score, AI ideas plus human re-ranking are better than human ideas. So those are the three conclusions that will hold across a bunch of different tests that I'm gonna show you. So I'll go through three different tests. The first one is, what if we just treat each review as an independent data point? And that means I just aggregate all the reviews for each condition. And this is a bar plot showing that result. So you can see that in the first subplot, both the AI conditions are higher than the human condition. And same thing for excitement. And for feasibility, you can see that actually the AI ideas tend to be lower than the human condition. And then for effectiveness and overall score, pretty much similar. And I can show you the detailed numbers as well. Essentially, you can see that the 3 red rows are the rows that will hold across all the different tests. And all the p-values are much smaller than 0.05. So we consider that as significant. So this is the first test. There's some concern about this test in the sense that we're treating each review as a data point, but we're actually sampling multiple reviews for each idea. So maybe a better way of doing it is, what if we treat each idea as an independent data point? And that just means there will be only 49 data points for each condition, because there are only 49 ideas from each condition, where we actually aggregate all the review scores for each idea and treat that as one independent data point. If we do that test and we still run the 2-tailed t-test, you realize the 3 rows, they still have p-values smaller than 0.05, so they still hold when we account for this confounder. And another potential concern is, what if different reviewers, they have different standards? Some reviewer tends to be more lenient, some reviewer tends to give lower scores in general. So one way to account for that is we just treat each reviewer as an independent data point, where we'll aggregate the reviews across different conditions. So if we do this and we run the one sample t-test, you see that across all the reviewers, people are giving higher scores to the AI. The main difference here is basically people's average score for the AI ideas minus people's score for the human ideas. So the difference bigger than 0 means people are consistently giving higher score to the AI conditions. And you can see that those 3 rows still hold under this test. So the conclusion across different tests is that when we run all these tests accounting for all the different confounders, these 3 conclusions hold robustly across all of them. And that is the high-level takeaway for the results section. Any question on this part? Yes.
I'm sorry, I came in a little bit late, so I didn't really see it. But I mean, do you control for the expression of those ideas? I mean, basically ask AI to rewrite human idea in the same format. Maybe
Yes.
AI is just better at explaining text to humans.
Exactly. We run this style standardization module where we specify you should adjust all the human AI ideas to have the exact same writing style.
Okay, good. Thanks.
Yes.
Were AI ideas more feasible than human ones, or was it the other way around?
No. In the bar plot, we're showing AI ideas tend to have lower feasibility score.
What was the distribution across topics? I'm curious, like were some topics more feasible or novel than others?
Yeah. There is some difference across different topics. Some topics tend to just have higher score in general, while some topics tend to have lower scores in general. We have this breakdown in the appendix of the paper. I didn't include that here because if you run a statistical test, the difference across different topics is not really significant. So it's hard to make a convincing conclusion there.
And was your distribution across these different reviewers across these different topics equal, or was it skewed? Like some researchers are more experts in other fields than other researchers.
Yeah.
And how did that factor into quantifying novelty or really the other thing?
Yeah. So when we are assigning the ideas to people to review, we would first ask for their preferred topic, like what's the topic you're most familiar with, and then we match based on their preference. And we have this test where we ask people on a scale of 1 to 5, what's your familiarity with the topic that you're reviewing? And our average is close to 4. So people are generally pretty familiar with the topic they're reviewing. Go ahead.
What's the copyright on the ideas?
What's the what?
Copyright.
Who owns the ideas?
Yeah, so
OpenAI.
That's a very good question. So in the IRB statement, what we said is that you're contributing a data point to us, so we get to do what we want with these ideas. We're saying that because we'll be using these ideas for the second stage of execution study as well, where we'll assign all the submitted ideas to some people to execute. So that will be an independent group of people. But when it comes to if someone is finishing those ideas and wants to publish those ideas, what we said is we will put both the idea writer and the executor as co-authors on the final paper.
So we have to get more papers.
Go ahead.
Was there any consideration to use like LLMs for re-ranking?
There is some consideration on that. Later I will touch on this point on LM is not very good as evaluator yet, but I think based on that table I showed, we do think it's doing something in the right direction. It's on a high level, it's able to distinguish the better ones and the worst ones, but it's not working perfectly yet. Okay.
In the idea generation stage, as you're iterating through this, how many unique ideas we're actually generating each step? Because I can imagine occasionally you would get the same idea just presented in a slightly different context.
Yeah. We have a whole section talking about that in later part of the talk.
Okay.
Okay. Yeah, go ahead.
Just in general, like, you know, I mean, there's a science to innovation. There's this, like, how do new ideas are born? And one of my favorite theories about new is the so-called adjacent possible. And so basically saying like a new idea opens up a space of nearby new ideas. So through simple recombination of concepts, you can actually push the boundary forward. So, you know, so it's basically large language models can do that thing better than humans can.
Yeah, that's a good
Are you
point.
familiar? Like, you should look up the adjacent possible as the theory. Steve Strogatz has a paper on that, the model, and there's other.
Awesome. Thank you for the pointer. I'll definitely read that. All right. I will move on to the next section then. All right. So I talked a little bit about the high-level results. Next, I want to address some of the concerns that people had. I will start by saying you're absolutely right that people are not necessarily giving us their best ideas. In fact, we did a survey of all the people who wrote ideas for us. Of the 49 of them, 37 of them came up with an idea on the spot. And then we also asked this question, like, please rank your submitted idea among all the ideas you ever worked on. And on average, people indicate that their submitted ideas indicate about top 40% of all their ideas. So these two stats combined, I think this is really showing that the ideas that we're collecting probably represent the average of these people's ideas rather than their best ideas. So this is an important limitation we want to point out. And there's some limitation in the reviews as well. As you can imagine, reviewing is just incredibly noisy in general. So we acknowledge that reviewers have a pretty low agreement across the board. We use this metric called consistency, where for each idea, I split the reviewers into two halves. I will get the binary accept reject decisions based on the first half, and I measure the agreement with the second half. If I do this consistency metric, I realize the consistency based on our reviews is about 56%. I mean, that is higher than random, but that's also lower than actual conferences like NeurIPS or ICLR. And to me, that's somewhat expanded in the sense that reviewing ideas is something that I will consider even more subjective than reviewing papers, because when reviewing papers, you at least get to see the actual experiment outcomes. So lower agreement on review, that's one limitation I want to point out as well. But still, I think we are definitely getting some positive signal despite all the low agreement here. So that's two important limitations. And next, I'll show you some actual examples of the generated ideas. Each idea is very long because we have a very detailed template. So here I'm showing you two ideas on this uncertainty topic. And I'm extracting the most important sections out of the ideas, namely the proposed method sections. I can tell you out of these two, one of them is AI generated, and the other one is human generated. And well, when I did this talk at Stanford, I would ask people to vote on the spot, which one do we think is better. I guess maybe you can do something similar here. So I will first just summarize the two ideas for you. Right. So the first idea is called modular calibration for long form answers, where the goal is to quantify the uncertainty of a long form answer. The way you do that is you decompose the long form answer into multiple sub-steps. You estimate the confidence of each step, and then you aggregate them to get the overall confidence of the long form answer. And the second idea is called semantic resonance uncertainty quantification, where the idea is you generate multiple different solutions for your query, and then you can construct a graph where you treat each solution as a node, and you treat the agreement between each pair of solutions as the weight of the edge in the graph. And then you can use graph centrality measures like page rank centrality or whatever centrality you want to estimate the uncertainty of each solution node. So those are the two ideas. I guess we can, okay. So I'm gonna ask, how many people think idea 1 is more novel? Okay, 1%. And how many people here think idea 2 is more novel?
Can I, are you going to ask another question about human or versus AI?
Yeah, I'm actually, let's first settle the novelty question, maybe. Any other people want to vote?
I have some votes on Zoom for number 2.
Okay. So let's just say that about the same, maybe slight preference for idea 2. Okay. So some people are asking about human versus AI. I guess we can do that as well. How many people think idea 1 is from human? Okay.
And idea two, I think idea 2 is the AI idea.
Okay.
Idea 2 is AI.
Okay. Anyone else who disagrees? Okay. Okay. So I think from the vote on the spot, I will make this conclusion. I will say usually I think there's still some subtle cue in the writing or whatever the content of the 2 ideas that people are actually able to tell. You're actually right that the second idea is from AI and the first idea is from human. We tried our best to account for this writing and style thing, but still, there's no way you can 100% exclude that. So maybe to some extent, people can still tell apart human versus AI ideas. But still, when doing the evaluation, we're really asking a question of which one do you think is better in terms of novelty, excitement, etc. So I will argue that's a separate question than the identity of the ideas.
But you know what gave it to me away? Like it was combining this buzzwords,
Exactly.
like to get throwing them together.
Right.
And it sounds good, but you think that's like, oh, like, what does it actually mean? It's like, but it's a common pitfall that humans also fall into sometimes.
I agree. And that's exactly why I think the result makes sense in the sense that these ideas tend to get higher novelty scores, but lower feasibility scores. When you actually think about whether it's possible to execute these ideas. And later on in the reviews, I'll also show examples. Yes, go ahead.
So when you're measuring novelty, is it based on methods or is it based on the problem itself? Because if you're looking at centrality measures, it's not super novel. So how do you, are there different categorizations of taxonomies of novelty? Or
in the definition, we just said treat the whole idea and then put a judgment on that. Yeah. Okay, so these are the proposed method sections. I will just quickly show you what the whole ideas look like to give you a sense of what's the format we're using. So for each idea, we'll include the problem statement, the motivation sections, the proposed method sections, and also the experiment plan sections. In the experiment plan, we'll ask people or an agent to include what data sets to use, what's the baseline to compare with, how to implement the proposed method, what evaluation metrics to use, what analysis to run, what ablation studies to run, etc., etc. So we try to make it as detailed as possible so that if you give these ideas to a student, they can actually execute these ideas.
Wait, one more question. Did you ask the LLMs to evaluate, to review the ideas as well?
No, we only ask human experts to review. Yeah. We will touch on whether it's possible to use LLM as evaluator later. Right, and also a bunch of test case examples. So that's the format of the human written and also AI generated ideas. And also, this just some examples of how people write reviews. Numerical score for each dimension and also a free text professional. So if we look at the example on the right, we can see that people are including off archive links to justify the review. And people are also picking up on some of the very detailed components of the idea. For example, this person is saying, if you use multicolor dropout as your baseline, then you can't really use closed models because you will need access to the model weights, then you will need GPU to execute the idea, blah, blah, blah. So I would say the reviews are rather detailed, and then generally I would consider them to have pretty high quality. So just some concrete examples of the idea and reviews. We also did some analysis of the free text rationales that people submitted in their reviews. So I'll just summarize some common failure modes of AI ideas. All of the AI ideas tend to be a little bit vague on the implementation details. They'll tell you you should run blah, blah, blah without telling you how exactly you do that. And then common issue is also we tend to use the wrong data sets or inappropriate baselines in the experiment plans, sometimes making unrealistic assumptions or require a lot of resources that are just impossible for academic labs to execute. So those are some of the common weaknesses of AI ideas. And on the other hand, human ideas tend to have a different style in the sense that human ideas tend to focus on very common and practical problems that people already realize in the field. And they are much more grounded in existing research and practical considerations. The trade-off is that they may be perceived as less novel in that sense. So that's the intuitive high-level summary of the trends of AI ideas versus human ideas. Any other questions on this part? Okay, if not, I'll talk a little bit about the limitation of large language models themselves. So when talking about the idea generation agents, there are two ideas that we want to leverage. So we want to massively overgenerate a lot of different ideas, and I want to do some re-ranking to find the best ones among them. We'll review whether LLMs are really good at these two things. The first one is the diversity issue. So we said we are gonna overgenerate tons of ideas for each topic. And then there's this question of what if the model is just repeating the same ideas over and over again. So we want to measure whether that's actually the case. So on the left, I'm showing when I keep generating ideas, how many of them are actually new ideas that are not duplicates with existing generated ideas. So you can see that there's a very clear decline. As you generate more ideas, at the later batches, most of ideas will just be duplicates.
Wait, how do you identify duplicate ideas?
Yeah, so we use sentence transformer to embed all the ideas, and we set a threshold on the semantic similarity.
Oh.
So let's say if a pair of idea has a similarity of above 0.8 something, then we consider that as a duplicate.
Okay, I see.
Yeah. And on the right, I'm showing the accumulated total number of non-duplicate ideas among all the generations. And you can see that even if I'm generating 4,000 ideas for each topic, overall, there are only about 200 non-duplicate ideas. So very bad at diversity for current language models. Another concern that we had is also, some people also brought this up, and that is whether we can possibly use language model to evaluate all these ideas. So we did this quick evaluation where we still use the consistency metric to measure the agreement between the evaluator and the actual expert judgment. So here on the bottom half, I'm evaluating a bunch of LLM evaluators. So based on GB4O, cost 3.5, and also the last one is an existing implementation from another paper. So the number here means the agreement between this LLM evaluator and the actual human expert judgment. You can see the agreement is pretty much close to random for all these different automatic reviewers. So I would say current language models are definitely not ready to do this automatic evaluation job yet. And it just seems a little bit concerning to me whether all such AI science papers should be using any sort of LLM evaluator in their evaluations without actual grounding with human expert judgment. So that's a limitation on LLM as an evaluator. Any question on this part? Okay, so that's the major limitations of large language models. So up until this point, that's mostly what we did in this current study. And then for the next section, I actually want to spend a couple of minutes talking about a bunch of ongoing and also future slides that we want to run. The first one is this execution study that I already mentioned. So in the study I just talked about, we recruited a bunch of people to write ideas for us. We also generate a bunch of ideas with the AI agents. But all the evaluation is really done on the idea level. And there is concern that maybe people are giving higher novelty scores to AI ideas just because they like to use more buzzwords, they look more exciting. But if you are trying to execute them, they might not give you good results in the end. Want to test whether that is indeed the case. The way we test that is we're going to recruit a bunch of people to execute all these ideas in full projects. Again, we're still in the middle of this study. We're still looking for more people. So there's a sign up link if you are interested. I want to talk a little bit about the experience of running this execution study. So a couple of weeks ago, I actually executed the AI idea myself. I put a GitHub link here. It includes all the implementation and also experiment results. You can check the repo if you're interested. That is the AI idea that I showed you earlier in the talk, right? So if I actually implement the idea, does it work? Well, first of all, with reasonable modification, you can make it execute. Like you can actually implement the idea, you can run the proposed experiments, you can compare it with some existing baselines on the mentioned data sets. It works a little bit on the second case, like with future prompting, you do see a slight improvement on AUC if you look at that metric, but overall, very marginal impact as compared to the other baselines. So I would say pretty mediocre effectiveness if you look at this particular experiment.
Does this qualify you as the first servant of the algorithm?
You can say that, yeah. And the thing that I want to highlight even more is to make the idea actually execute, I have to do a bunch of work on the idea itself. So here I actually did a run of annotation where I'm proposing a bunch of changes to the original AI generated idea, along with some rationales on why those changes are necessary. So for example, here one of the baseline is multi-color dropout, and I'm adding a note that if we're using OS models as the models for evaluation, then we shouldn't be using that baseline because we don't have weight access to that, so we can't run that. And also, one of the data sets just doesn't make sense for this particular setup, and one of the metrics also doesn't make sense for measuring calibration, blah, blah, blah. So I have to make a list of modifications just to make this happen. And for our execution study, we're also asking our participants to do such.
Did you input those feedback back to the model? So it kind of like learn, oh.
So we'll collect all such modifications for all the ideas we have, and we'll definitely do something with this data. Whether we want to use that to improve the model or make it a benchmark, I think we'll discuss that later. Yeah. All right, so this is the execution study that we're running right now. And some other things we're considering. So EMLP is coming up next week. There's this complaint that we're only getting average ideas from our human participants. What if we want a stronger human baseline? I will consider papers accepted at EMLP as a stronger baseline in the sense that those papers, they pass the peer review, they probably represent some of the best ideas that researchers have. So we actually generated a bunch of ideas a while ago, and we want to compare those ideas with EMLP proceedings to see whether the trend will be different. And another thing we are thinking about is also this task on automatic execution. In the beginning, I said the goal of the researcher agenda is really I can generate a bunch of ideas and automatically execute of them so I can know whether each idea works or not. So far, I only talk about generating ideas. What about execution? So the task format will be, I will give the idea as an input to the agent, and I hope the agent can generate the full code base to actually run experiments. So essentially do whatever I did myself manually. This is an incredibly difficult task. We did some preliminary experiments. The last section in the appendix of the paper is actually discussing some experiments on that. This high-level summary is this task is difficult in the sense that you can't just evaluate on the final outcome. You also have to check whether the agent is skipping some intermediate steps, or is it implementing the metric run, is it implementing the baseline run, etc., etc. So it's a much more involved task than traditional code generation. So we need more work to make it actually work. One last point I want to make is this idea of estimating an upper bound. So I was giving this talk at Stanford HCI group a while ago, and I got asked this question, what do you think is the most impressive thing that AI generated idea can ever achieve? One concrete milestone is if I submit something generated by AI to neurons, can I get an auto? I do think there's some possibility to make it happen in the next few years. And I think on a broader level, this is really asking what's the upper bound that we can ever achieve with this automatic idea generation paradigm. And I think so far, all the results I'm showing, there are tons of things that we can do to further improve idea generation. So I don't think we're really touching the upper bound yet. So I think it'll be exciting to spend the next few years to further improve this whole pipeline and see really what's the most impressive, what's the one single most impressive idea that AI can possibly generate, and what's the impact of such ideas. And with all that, that's pretty much the what we've been up to over the past 1 year or so, and what are the plans that we have for the next 1 year or so. I will conclude the presentation here. I'm happy to take any questions or feedback.
Okay, yeah, thank you. So can we give a round of applause to the speaker? Let's start with an online question from Joseph Wang. So he asks, how do you plan on researchers implementing ideas that are proposed by AI but judged to be highly infeasible, i.e. they could be throwing together buzzwords from different disciplines that might not actually be compatible?
Yeah, so that's why we are having this modification step first. So I will ask all my participants to first go through this step of reading through the idea and proposing a bunch of modifications. If they think even within like all the possible modifications, the idea is still infeasible, we'll just abandon that idea and switch to another idea.
Any questions from the room? I'll go to the next one. So like, can you speak a little bit more to, like, I know there's the AI researcher that's working on similar things, and I know there's your study. Can you talk a little bit more about like the space and like who's working on this problem?
Yeah, so there's a science paper from psychology people where they build a system that can do end-to-end automatic research, including the paper writing step as well. I actually include that in the related work section as well. And there have been a bunch of other attempts on using language models to generate ideas. But as I said, I think the key difference is really all those works are more focusing on system building rather than evaluation. So I think all those are cool work, but I think we definitely need some grounding on evaluation to help us understand what's the progress in system building. So that's where I see the value of our whole line of work. Go ahead.
Not sure you mentioned it, but what kind of LLMs do you use? And like, have you noticed any like better novelty score for certain LLMs? Definitely not for personal use.
For this particular study, we're using Cloud 3.5 as the underlying base model. The reason why we use that is that in the development stage, we tried a bunch of different models, including OpenAI models and a bunch of other models. We didn't run like large-scale quantitative evaluation of those because that's very expensive. We just did a vibe check where me, Dee, and Tasu were sitting down together and look at all the different ideas generated by different models. We feel like Cloud 3.5 is doing a better job. That's why we picked Cloud 3.5. Go ahead.
Yeah. So again, like in the science, like, you know, people who study science of science and innovation, there's evidence that some of the, you know, good ideas, novel ideas come from like interdisciplinary, several different fields kind of, you know, combined. It's like, did you prompt, I mean, I missed the first part, few minutes of your talk. So did you prompt the LLM to consider these different interdisciplinary type of merges?
That's a great idea. In this current version, not yet. But that's one idea that my advisor D has been trying to push me to work on for a long time. So that's definitely on the list.
And in fact, you know, the usual barrier to this type of interdisciplinary ideas is the fact that different disciplines speak different jargons.
Exactly.
And for humans, it's difficult, but for LLMs, it's not difficult to
Exactly. Yeah. Yeah. Because I think both D and I care about complementing humans rather than you know, replacing humans and trying to, you know, cross the interdisciplinary barrier. It feels like a great case where AI is able to offer something that potentially complement humans. Go ahead.
I think I can want to build on that. What do we have, like a round robin council of LLMs agents, and then they all try like bounce off at each other, and then they will have to agree on the one final idea.
Oh, like an adversarial type of.
Yeah. And then see if that improved the novelty now that they have like a little bit check and balance between the LLM agents.
Exactly. Yeah. Yeah. I think extending this to a multi-agent setting is also something we've been thinking about as well. Because one argument is humans, they don't just, you know, work by themselves. They like to discuss their idea with a bunch of others. So maybe such discussion among agents with different expertise or backgrounds could further improve idea generation as well.
Can I get $300 from that?
Interesting.
All right. Can you talk about ethical implications?
Yes. So there are a bunch of things that we could possibly talk about here. One thing I think already came up during discussion is who takes credit for AI generated ideas. I'll be very honest. I don't think I have the good answer here. I think this is something very new. I think we are entering a very new stage where AI is gonna get increasingly used in academic research. To us, at least personally, I think the bottom line of this whole paradigm of doing research is that if your idea comes from AI, you should definitely make it clear in the paper that the idea comes from AI, and you should elaborate how exactly you use AI in coming up with the idea. But whether you should include AI as a co-author, I'm not so sure about that, because that touches on all of things. Like, what if the general idea is heavily inspired by something in the pre-training data? Should you also credit those things? But then it goes down into the rabbit hole of tracing down the impact of pre-training data on the model generation, and that's just a lot of trouble with all the black models. So I think we definitely need more thinking on how to credit things in this new paradigm, but very transparent acknowledgement of how AI is used. I think that's the bottom line here.
Well, what about the idea like this will replace knowledge workers and replace PhD students? We don't need PhD students anymore. We don't need people to graduate and go work for companies because companies can control which ideas they generate.
I think at least for now, our results are showing it's not really at a stage where it can.
But you're trying to make it better.
Yes, I agree. That's why I also said we will try to move towards the complementing humans angle, and interdisciplinary idea is just one great example. And more broadly, I think we're trying to explore ways where this whole idea generation thing can collaborate with humans. So here, one thing that we tried is, what if we ask humans to re-rank the AI generated ideas, and we showed that that condition is indeed better than just using AI ideas alone. But there are definitely better ways of doing this collaboration. So for example, what if I use AI ideas as an inspiration for humans? Humans can still throw in their feedback on additional ideas to the AI agent, and then they do this iterative brainstorming thing back and forth. I'm sure that could come up with better ideas than just AI thinking by itself. So I think we need to first understand where we are right now with the current language models. And then I think that's going to inform us on how to explore possible new ways of collaboration paradigms. So that's my stand on this. And also touch a little bit on the execution thing. I do think automatic execution is actually a great tool for researchers, in the sense that a lot of people have been complaining to me, they have a lot of ideas. The bottleneck is they don't have enough time to execute all of them. So if we manage to build a tool that can automatically execute ideas, I say that's a great way to complement humans, where once you have an idea, you just give your idea to an AI to execute. I think to a lot of people, they care more about the coming up with idea stage rather than coding and implementing the idea. So feels like this will be a great tool to complement humans as well. Go ahead.
Have you played around it? Oh, sorry.
No, go ahead.
Have you played around at all with generating ideas around human subject studies or simulation-based studies? Because I feel like I'm curious how, if you're trying to generalize, draw too many conclusions from generating ideas just for NLP focused research.
Yeah. So that's a great question. I've actually been exploring, like, extending this beyond just prompting topics. So I was playing around with generating ideas on topics like scalable oversight, where the goal is to help humans better supervise AI or overseeing AI outputs. There was also some other attempt that I did earlier, where we're trying to see if we can automate parts of the HCI study. In that case, the execution is not generating code, but rather doing human study. So for that thing, we actually built an interviewer bot, where I tell the AI what's the high-level research question, or what do I want to find out from all my human participants, and then I'll give that to an interviewer bot. The interviewer bot will figure out what questions to ask, etc. So different ways of automating research, but for HCI flavor. So I think there's a lot of possibility that we can extend this whole pipeline to other disciplines, but I have no guarantee on whether it's gonna work very well. I think different research domains have very different natures. I feel like this program will work great for those more empirical research fields. If it's more theory heavy, I'm not sure if this is gonna work well. So that's my intuition for now. Go ahead.
So just curious, when it generates ideas, you also ask it to answer where its inspiration came from, or what citations does it rely on to generate this, or what did it refer to? Usually when you ask it to summarize a concept, it comes up with a bunch of studies. And that is the first question. The second one is, would you also think that it's interesting to ask what is the delta of this idea over what has already been implemented, and then use that as sort of a rebuttal on the reviews, and ask reviewers again if these are, or see if the reviewers found these to be the delta. This is why this is novel, or what do you think?
We haven't tried those things yet, but they do sound very interesting. So one thing that I'm really hoping to dig further into is this idea of tracing down to, let's say, the inspiration, right? So right now we're not asking the model to give me citations on anything. The only thing we do is to append a bunch of related papers in the prompt when doing the idea generation. I agree. Maybe there will be a way for us to better track what's the inspiration of each idea. That can also open up new analysis that we can run, and also. I like your point on tracking the delta. We do have what I call a novelty check module when doing the re-ranking thing. And that is basically for each generated idea, I do another round of paper search to find the most relevant ones. But we haven't designed very complicated trap lines to include the delta idea to inform review or improve the idea generation. So I think that's one interesting idea to explore.
Great. Well, we're at time. Can we do one more last round of applause? Yeah, thank you for coming to speak with us. This is fantastic.
Thank you.